Well, this lesson is about angle relationships. So we're going to reason abstractly and quantitatively and construct viable arguments. Previously, you've measured and classified angles. Now you're going to identify and use special pairs of angles and identify perpendicular lines. We have some new vocabulary: adjacent angles, a linear pair, vertical angles, complementary angles, supplementary angles, perpendicular. So we've got a key concept here. What we need to know about this is that some pairs of angles are special because of how they're positioned in relationship to each other. There are three of the angle pairs described in this key concept. There's adjacent angles, and so they give you an example and a non-example. Now in a non-example, they share interior points, so that's why angle 3, which is this one, and angle ABC are not adjacent, because we're talking about sharing these interior points. And this one, they have no common side. Angle 3 and angle ABC don't have a common side. Then there's the linear pair. And a linear pair, well, we're going to learn that later in the lesson, but a linear pair forms 180 degrees. And this one's not, the way this is formed, it's not 180 degrees, not a straight line. And then there are vertical angles, and they're formed by two non-adjacent angles. They're formed by two intersecting lines. So 1 and 2 are vertical, and 3 and 4 are vertical. But these aren't lines, these are a bunch of rays meeting together, so we don't have vertical angles there. We cannot assume that. So let's identify some angle pairs. They give us some roads here, and they want us to name an angle pair that satisfies the condition two angles that form a linear pair. A linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So these are examples. You could choose either one of these. There's three choices here that we could choose. So why don't you pause for a minute and examine each of those angles to see what makes them a linear pair. Okay, now we have these same roadways, but they want us to name an angle pair that satisfies the condition two acute vertical angles. So pause for a moment and study those. Here are some possible answers. You could choose this selection, or the angle PIQ and angle TIS, or angle QIR and angle TIU. So pause a moment and check out each one of these angle pairs to see what's happening there. Okay, now time to check your progress. We are to name two adjacent angles whose sum is less than 90. So pause the video, figure out which two adjacent angles sum is less than 90. Awesome. FAE, so FAE is 30 and FAN is 55. So together they're adjacent, they're next to each other, they share a common side, but no shared interior points. And their sum is 85, so that's less than 90. How about two acute vertical angles? So pause the video for a moment to see that. Okay, FAN and DAC. So you know that they have the same measurement, 55. Okay, very good. See, BAC is given, but its vertical angle is FAE or EAF, and it's paired with CAE, so that is not correct. So you can see why some of these are not the good choices. Okay, let's talk a little bit about angle pair relationships. Now, some pairs of angles are special because of the relationship between the angle measures. So here we've got that vertical angles are congruent, which we talked about just a little bit ago. Complementary angles. Now, sometimes it's difficult to remember the measurement of complementary and the measurement of supplementary, but just know that C comes before S in the alphabet, right? And when you're counting 1 to 200, 90 comes before 180. So C comes before and 90 comes before, supplementary and 180. So you can remember that C is the smaller number and S is the larger number. And maybe that'll help you keep it straightened out. The angles in a linear pair are supplementary. So we talked about that just a minute ago, that these two will equal 180 degrees. So pause for a moment and study these diagrams so that you understand what we're about to do here in a little bit in the next examples. Okay, let's talk about angle measure. We are to find the measures of two supplementary angles if the measure of one angle is 6 less. So what are we going to do right here? Are we going to go 6 minus or minus 6? Yeah, when it's 6 less than, that means we're going to minus 6. We're going to take 6 away from 5 times the measure of the other angle. So first of all, we need to know that supplementary means we're talking about a measurement of 180. If we draw the two figures, and we're going to let X represent one of them, so then the other one is 5 times 6, or 6 less than 5 times the measure of the other angle. Okay, so we know together that the measurement of angle A and the measurement of angle B is equal to 180. We're told they're supplementary. We know that the two measures together are going to equal 180. Now we can substitute. If we know the measurement of angle A is X and the measurement of angle B is 5X minus 6, now we're just going to combine our like terms. X plus 5X is 6X. We're going to add 6 to both sides, divide both sides by 6, so we know that X is 31. Are we finished? Oh, nope, because we were asked to find the angle measure. So we know what X is. So we know the measurement of angle A is 31. We have to do a little bit more math to find the measurement of angle B. We're going to substitute that 31 in for X, multiply it by 5, and then subtract 6. Now we can add the angle measures to verify that they're supplementary. Is 149 plus 31 180? Well, let's see. Well, by golly, it is. All right, good job. We've got that one. So our answer is the measurement of angle A is equal to 31, and the measure of angle B is equal to 149. Now it's time for you to check your progress. We're to find the measure of two complementary angles if one angle measures 6 degrees less than 5 times the measure of the other. So pause, work this one out, and then select your answer. Good job. We set it up just like we did the other one. We're going to have X plus 5X minus 6, but this time it's equal to 90. So X is going to be equal to 16, and the measurement of one is 16 and the measurement of the other angle is 74 degrees. Awesome job. Lines, segments, or rays that form right angles are perpendicular. And so here we're given key concepts about perpendicular lines. Now you're very familiar with perpendicular lines, so I'm not going to insult your intelligence by reading this to you. I would like for you to pause the video and look at this, read it through, and study the diagram, and then we'll continue on. Okay, so now we're going to use algebra and what we know about perpendicular lines to find the measurement of different angles. They're wanting us to find X and Y so that line KO and line HM are perpendicular. So if they're perpendicular, we know they form right angles, right? So if line KO is perpendicular to line HM, then the measurement of KJH is equal to 90. So we're going to find X, knowing that these two together are equal to 90. And then we're going to use KJI and IJH. These two together, they add together to give you the measurement of angle KJH, and we know that KJH is equal to 90. The measurement of angle KJI is 3x plus 6, and the measurement of angle IJH is 9x. So then I'm going to combine my like terms. 9 and 3 is 12. Subtract 6 from both sides. So x is equal to 7. Now we're going to find y, and we're going to use measurement of angle MJO, which we were told in the diagram is equal to 3y plus 6. And we know that angle's 90 degrees because we're calculating it if it were perpendicular. So if it were perpendicular, it'd have to be equal to 90. We're going to subtract 6 from both sides, divide both sides by 3. So x is equal to 7 and y is equal to 28. If you are a little bit confused, why don't you go back and look at the diagram? Perhaps draw that diagram in your notes and then go back and you can see as it's worked how that comes out to be. All right, time to check your progress. So we're to find x so that line AD and line CE are perpendicular. So take just a moment, pause the video and work that problem. Did you get that x is equal to 10? Because we know that 4x plus 5x is equal to 90, don't we? It would equal 90 if they're perpendicular. So 4x plus 5x is equal to 90. So 9x is equal to 90. So x is equal to 10. All right, good job. Now there's a few things that can and cannot be assumed. Things that cannot be assumed must be marked, or we must be given this information. So we can't just assume that HM is perpendicular to HL, can we? So I want you to pause for a moment and I want you to read through each of these to give you an idea when we're working what you can say is happening in the problem, what you can assume, and what you cannot assume. Okay, we're determining to determine whether the following statement can be justified from the figure below and then explain. So can we assume that the measurement of angle VYT is equal to 90? VYT. Can we assume it's equal to 90? So the diagram is marked to show that VY is perpendicular to TX. From definition of perpendicular, perpendicular lines intersect to form congruent adjacent angles. So yes, we can say that they are perpendicular, that they are equal to 90. Can we determine whether angle TYW and TYU are supplementary? Yes, they form a linear pair. TYW, TYU, there's that linear pair, sure enough. Okay, so a linear pair by definition is 180 degrees, which is supplementary. Okay, another one. Determine whether we can say angle VYW and TYS are adjacent. VYW and TYS, are they adjacent? Nope, they don't have a common side. Okay, so now we know what it means by explain. We have to say yes or no and tell what makes that true or not true. So time to check your progress. You've got 3 to work here yourself. So pause for a moment and tell me, can you determine whether the statement, the measurement of angle XAY is equal to 90, can it be assumed from that figure? No, it cannot. It's not marked with a perpendicular showing that that's a 90-degree angle. So we can't assume that. Okay, pause for a moment. Can you determine the statement angle TAU is complementary to UAY? Can that be assumed? No, you can't. Looks to me like TAU and UAY are supplementary. Okay. Determine whether the statement angle UAX and UXA can be assumed from the figure. Well, adjacent angles share a common interior side, and UAX and UXA have some common interior points, so nope, we cannot determine that from this statement. Okay, you are ready to begin the exercises.